name's Vince from mymatevince.com, and in this video today it's not so much a trying to fix video, maybe more a trying to work out video. We've got a faulty one of these in here. This is a new one that I can use for replacement parts, and basically it blew up. So what caused it to blow up? This one here was originally owned by Kip Hakes and it's been installed in his kitchen for a while. It hasn't had a huge amount of use, but a few weeks ago it blew up. He did a video on it to just have a autopsy on the inside, look on the inside to see what was wrong, and he suggested that maybe I might like to take a look at it, and I thought actually that would be quite interesting because we're going to have a bit of a power supply, a switch mode power supply going on here, aren't we, to convert it from 240 volts down to the 5 volts that the USB needs. And when I recently did the Ministry of Sound power supply there, I found it really challenging, really challenging, but also kind of interesting. So I'm hoping maybe I might be able to, by swapping a few components out, find out what the problem is. So I'm just going to show you part of Kip's video now where he explains what happened.
I'm going to be performing an autopsy today, and I'm going to be performing it on this. Now the reason why I'm going to be doing that is the other day, on Friday night, Vicky was doing some cleaning in the kitchen, and this socket was on the wall, and she was cleaning by it. It didn't have any load into it, everything was unplugged, and she was just cleaning around it. And all of a sudden I heard a very loud pop and then a very loud scream, and I went running into the kitchen to find Vicky looking a bit shaken up and sort of pointing the socket, and she's just said that just went bang. So I had a little look, and the rest of the electrics in the kitchen hadn't tripped and none of the other electrics in the house had, so I didn't really know what had happened, and we were just standing there discussing it further, and it made another popping sound, and yeah, there was a sort of flash of light from it, and then some smoke and a horrible burning smell.
So there we go, very interesting. I will of course link to Kip's video down in the description down below. Now while I'm taking this out here, I'm going to show you another part of Kip's video now where he initially takes it apart to show you the burning on the inside.
Whoa, okay. So yeah, as you can see there's quite the burnie. That's really popped. That really has, yep, that is a fine smelling vintage.
Now, so as you can see there, it looks very burnt on the inside. Annoyingly, it's one of these things where I'd like to do it where I don't end up breaking the socket, but I'm going to have to because we have these earth bar here like riveted onto here. So basically this is just so you know when you're using a metal back box that it's earthed through the screws off the back box via here. Otherwise what could happen is where the mains cable comes in, if for example the grommet had moved or no grommet was put in as it's going through the hole in the metal back box, it could rub against the cable, and then in theory the back box could become live without you even knowing it, and then you could get a shock from touching the screws. So by having the screws connected to the earth bar here, it's going to trip the breaker, isn't it? Right, just in case you haven't watched my channel before, I am not an expert whatsoever in these things here or anything electronics related. It's more about trying to learn along with the viewers, and then I get help from the viewers, and then often in revisit videos it can be fixed then. So if you want to know about this sort of stuff, then obviously there's channels like bigclive.com, and he knows what he's talking about, while with this one here I'm just going to be trying to work out what happened to it. Will I be successful? I don't know. I think the very fact that I've got this one here, and I presume this is going to be a working one, I haven't tried it yet, but I'm thinking if I take components out of this, there's a good chance I might be able to pinpoint what the problem is. Right, okay, so we've got 3 pins. We're going to have the earth, the live. So this is the switch one here, so I presume that's going to be the live, this one here, and this is going to be neutral. So neutral's connected through to there, this wire is spot welded onto here, and there you go, it says N for neutral there, so that's definitely neutral. This is the live one here, and this is how the switch works up here. You can see when we switch it via these ones here, that it's going to be forcing this here between the back bit here and this bit here. So here we have the little power supply here, so we're going to have 240 volts AC going into here. We've got a fuse here, and this is going to be the bridge rectifier here, which converts it from AC to DC. So like Kip said, there's lots of charring around this side of the board here. To be fair, the output side, the USB side, kind of looks okay, doesn't it? So this is going to be the isolation through, is it going to be this area here, through this capacitor here, across here. So that part of the board, is that the isolation there? So that does look okay. So now the live goes through the fuse. So this is a T 3.15, so 3.15 amps at, let me zoom in a bit, at 250 volts. Right, should we first of all see if the fuse has blown? Presume it has. So we're going to put our meter into continuity mode so it beeps when we hit the leads together. Okay, so the fuse has definitely blown. Now from here, it goes up on this trace here, which is completely burnt through. I'm wondering whether the bridge rectifier has blown. Now, how do I test? So this is going to be the AC coming in, and this is DC going out. How do I, let me go to Diode Test. Now, what do I do? Do I go from one? I know on a PlayStation and stuff, I just go across them all. So nothing there, nothing there, nothing there. Oh yeah, something there. Let me try that one now. There. Something there, something there, but that is a different reading there. So let me go between. No. That reading here looks like a short, doesn't it? There and there. Is that the problem? We haven't got a short there or a short there. I wonder, is the fault on the bridge rectifier? Where does it go to after that? So I'm just wondering, all this burning on the board, I mean it's burnt up here as well. Is that trace removed there? Yeah, it's burnt up here as well. Oh, and he said the capacitor, this capacitor had broken here. So from there, the DC, it goes into this capacitor, and then from there it goes up to this item here, which looks like a little transformer. So this is going to be the, oh hold on, we have a component here as well, some sort of transistor. Let's see if we can zoom in on that. Is there a chip on here? So is this the chip here that's going to be driving? Or no, would it be this side that the chip would be on? Maybe this is the chip here, which is driving the switching. It's kind of slightly hard just because we've got traces on the top and the bottom, and they're a little bit hard to see. Right, well, do you know, I'm sort of doubting myself, but I know on a bridge rectifier that it's like 4 diodes, and the reading I'm getting on my meter isn't a correct reading, because we should have open one way and then it's going to be whatever it was, 0.5 or 0.6 or something the other way. You can see 0.5, so I would say that's a normal reading, but that there is not a normal reading, that's just short. Yeah, and it looks like a normal reading here, but then if I was to go to here, that's not normal reading, so that's a short. So essentially what's happening is the AC is coming across, isn't it? And it's shorting straight onto the DC here. But you can definitely see where the fire occurred. I mean, look at that in here. My guess right now is that the bridge rectifier went, and because this is just always on. And I mean, why don't they put a separate little switch on here? Is it some kind of regulations where you're not allowed to have another switch? But why can't there be a little push button here, which is built into the board here? How much extra would that cost? I wonder, is it more regulations than anything else? Because then you could just press it when you want the power to the USBs and press it when you want to turn it off. That way then you haven't got the power going through all the time. I mean, it'd be so easy just to have from one of the cables here, you know, to break the circuit. Maybe you're not allowed to have it on the faceplate for some reason. Maybe there's some regulations that stops you from having that. So I'm just going to give this charred, burnt mess a clean with some isopropyl alcohol, and while I'm doing that, I'll shout out the My Mate Vince Massive. And this month, the members consist of Operational 117, KipDigital.com, Kip Hakes, he's the guy that actually sent in this socket, Max Rokotansky, Having Fun Repairs, Ellensburg Amplifier Repair and Service, Will Michaelis, Chris Seal, Dorian from Hooverlux Restorations, MediaSteamer.com, Rob Hughes, Felipe at MrKeebs.com, Dan Prutton, King Kurd from Low Book Auto Sales, and Kiki Hobby Repair. So massive thanks to everybody that gives support to this channel. Do you know, I bought the other socket thinking about changing components, but I believe Kip bought this 3 years ago and I only just bought this from Amazon now. So there's a good chance that the components inside might be different, might be a completely different board. Yet again, I've spilt the IPA over. I don't think I've gone through a video without knocking it over. Right, that's much easier to see now. So good news is, it doesn't look like the board's completely charred. To me, what it looks like is that maybe voltage has just gone down and kind of completely burnt out tracks, which is, so it's definitely burnt up here and around this area here, but the rest looks to be okay. Right, let's zoom out a bit and let's check the diode. There's a diode across here. Let's see if that's blown, and also there's a diode here. So nothing there. Right, so that looks okay, because we've got a read in one way, not the other. Nothing there. Yeah, so the two diodes look okay. Now, just thinking, rather than ruining this one, which I probably will have to do, at this moment in time, I'm thinking it might be just a fuse and a bridge rectifier. So I already have fuses of the same thing, T3.15 amps, 250 volts, left over from the power supply from the, remember I had to buy 10 of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah, I had to buy 10 of them from RS Components for the Ministry of Sound thing, and these are, I believe, the same ones. So I'm going to pop one of these in, and also I need to get a bridge rectifier. Now, a while ago, I bought a load of things from CPC, bridge rectifiers and stuff, after I think I did the power line adapter. Because on a power line adapter that got sent in, from memory, the problem with that was the bridge rectifier. So I bought a selection of bridge rectifiers, and also I think there's LEDs in here as well. The size of that one. So I am going to look up the spec of this one here. The ones that I need, it says on an ABS8. Let's have a look online on that one. Right, here we go. Farnell's do it. ABS8 multi-comp bridge rectifier, single phase, 1 amp. So yeah, that's it there. So now all I have to do is see what these are here. Right, I think I'm going to go with one of the bigger ones, because it's 600 volts, 2 amps, while the other one is, I didn't look at the voltage, but obviously it's going to be more than 240 volts, and it's 1 amp. So this is going to be rated for more. I can't see there being a problem with that, because it's only going to draw what it needs to draw, and we've got the fuse there to protect it anyway. They're only 29p each, 35p including that, so I think it's well worth the risk. The fuse as well, I can't remember how much they cost. I think like 20, 30, 40p, not expensive. So that's what I'm going to do. And as far as fitting is concerned, yes, this is much smaller, but if you have a look, you can see the traces did originally go down here. So I reckon when we put that on there in the correct orientation, that there, these two legs are actually going to fit perfectly. And with these two, I think it's going to be okay. I'll be able to just drag the solder over and go onto the capacitor here. Obviously, I need to just fix that leg that's broken there. But that's what I'm going to do, and we'll see if it works or not. If it doesn't work, I've got other spares to to put back in again, or just break this one. But it would be lovely if we didn't have to break this one. So while I'm doing this, kick back, relax, listen to a bit of music and watch me desolder the fuse and the bridge rectifier, and then solder in the new fuse and bridge rectifier, and also fix up the damaged traces and the capacitor along the way. I will be using a mixture of hot air to get the components off, and solder and a desoldering pump, and then just using solder and a wire to repair the damaged traces. Okay, so that's the bodge up job there, and I think that is going to be okay. I'm just going to add a bit more solder to that one there. There we go. This component here doesn't look too clever either, does it? That wasn't me, that was bent like that. So hold on, where does it go to? So this one goes up to here. Let me just see what my meter's doing. Right. Okay, so we've got continuity on that side there. Is this the negative side? Yes, but there's nothing here. Right, which is the negative for these caps here? Does that suggest that this component's gone? Maybe this component burnt out, because we've got, on that side we've got a full short, 0.3 ohms, and this side we've got nothing. So does that mean that the windings on this side is okay, but not this side? Who knows? Mind you, if that's open, that's not going to blow anything, is it? That's not actually going to cause a problem. It's just not going to work. Right, what I'm going to do is reassemble this in a way that I'm not going to kill myself when I add voltage to it, because obviously 240 volts is more than enough to easily kill you. So I'm just going to put it back together roughly so I can test it. I'm just going to give this a little clean while I'm here. So next time you see this will be back together, and I'll have to get, I think what I'm going to do is get a plug and some flex cable and just wire it up, and I can put it into, yeah, I can then stand away from it when I turn it on. So some of you might not have seen the UK plug before, but the top pin here is an earth, and on a plug, let me just get a plug. Here we go. Can you see that that is the earth is just slightly longer than the others? And so what happens is, the idea is that you can't shove anything into these here and cause damage to yourself unless you were to push down this top one. So because that's at an angle, when we plug this in here, it forces, hold on, it forces the shutter down, which then opens up the holes for the bottom two to go in, the live and the neutral, like that. And that really shows it very well, doesn't it, like that? Okay, this is going to be a bit of a jigsaw. It's going to take a while. I'll come back to it when I have it together. Right, so here's my flex cable. Just wired it into this plug here. Now, obviously, when I finish doing what I'm going to do, I will be disconnecting this, because if I leave this plugged in and then somebody plugs it in the future, this side here is going to be live. So, obviously, I need to disconnect all this when I'm done. This plug is horrible. When you get the older plugs that look kind of more like Bakelite or much harder plastic than this, everything's just nice because they've got like machine screws in these bits here, but this is just horrible. But anyway, that's it wired up there. So you've got the live going to the 13 amp fuse, which then travels down to this bit here, earth and neutral. Look at this. Oh, horrible. Anyway, it will do. Now look what I took out for this job. I haven't used these in years. These were given to me by one of my electrician friends when I was working for him years and years ago. He felt sorry for me struggling with my telecom tools, and yeah, he gave me this, and I must say it is amazingly nice. Expensive, but amazingly nice. So I haven't used it in years, so let's see now if I've still got the knack or not. Oh. Yeah. Have I broken any off there? No, I haven't scored any of the internal wires. Ah, lovely. Oh, this is bringing back happy memories. Stephen Power, if you're watching this, thank you. That's a great name for an electrician, isn't it? Power. That's his real name as well. Now, I'm not going to put it in the back box, this is only for testing. Yeah, also it's nicer when it's not done like this. Let me zoom in. Can you see what's happening is the screw is going to be going down onto the copper. It's nicer when the screw presses down, for example, if the screw was behind this and if it was to press down the metal. So this is being clamped by the metal rather than the screw. I wonder how come, and this is to do with money again, how come you can't get, or maybe you can get, but how come they haven't gone over to the spring fittings on these? So, you know, like with the Wago connections, I wonder how come you can't have like little Wagos built into here, which have maybe 1, 2 or 3 clamps for each one, so you can do your ring main and then your spur off it as well, and then they're always under contact. So it's because the copper is going to flow away from the point of contact. It will take many years, but it will flow away from this screw here. So in years to come, this will need tightening up. While if it was on a Wago type thing, which is under a spring, then it will always be under a load. Let me show you what a Wago looks like, because those of you who are new to my channel within the last few years probably haven't seen me mention them. Here they are. So you lift them up and then you put your cable into here, and this will do flex and solid core, this particular one, and then you clamp it down and it will join the 2 wires together, and it's maintenance free. So you can then put this in an enclosure and put it under floorboards and stuff. It's maintenance free, it's fine. Nice as well because you've got a little test point there that you can put your test probe into. You've got measurements on the back here, so it tells you how much wire to strip back. They're brilliant. German company, really good. They also do lighting connectors here and push fit as well. Yeah, so bigger cables and then your smaller cables here as well. But they're really good. Even these ones here, they're under a constant spring load. So I suppose it's all to do with cost. But it would be, maybe you can get the sockets like that. But it would be nice. Right, okay, let's plug it in and wait for the bang to happen. So which way should we have it? Should we have it this way here? So that's all safe, isn't it? Neutral, live, that one. I know I've wired that up correctly there. As I say in these videos, please do not copy what you see in this video because I feel safe doing this, but it doesn't mean that it is actually safe. And obviously there's no kids around to put their hands in here, and I'm not going to be having my hands anywhere near this when it's on. That's just the earth connection here, but I'm not going to be plugging anything in. All I'm worried about is this here. Right, let's plug it in and see what happens. Oh, here we go, ready for the bang. Get ready for the bang and the smoke. Let me move my light out of the way a bit. Now, how am I going to unplug? No, I'll tell you what I'm going to do. Can I unplug that? No, I'm just going to have to unplug it quickly. Right, here goes, here goes, here goes. We're in, we're in. It hasn't banged. It hasn't banged. Wow. Okay, I'm going to unplug it now, and then I'm going to get a USB meter to see whether it's registering 5 volts or not. Maybe it hasn't banged because of the, I've unplugged it. Maybe it hasn't banged because of the, that little transformer thing. Maybe that's not passing the signal through. Right, let me get a little meter. Oh, I've got one here. Right, so now let's plug this into here. Now let me angle it here so you can hopefully see that. Let's plug it in now and see if it does anything. I bet it doesn't. I bet that transformer's gone. Here goes, here goes. We're in. Ah, look at that, nothing. There's nothing there. Right, okay. Unplug it. I'm just going to try the other socket. Hello? There. Right, now let's see if it does anything that side. No! Right, unplugged again. I'm now going to plug in one of these just to see if it is actually, if the plugs are working, just in case I've wired it up wrong. Turn that on. Let's see if the lights come on there. Yeah, you can see 3 green lights there, so I've definitely wired it up correct. Don't know if you can see that or not. Yeah, you can. Right, okay, I need to take it apart, and I think unfortunately I am going to have to sacrifice the working one because I think I need to measure the transformer on this to see what it's doing. Who remembers this drill? I'm going to give it a go. Now apparently it's not actually safe to use because the battery management in the battery has, I've blown it, haven't I? So it's not going to, I don't know, maybe it could go on fire. Annoyingly, I haven't actually got a correct drill bit for this. I'm trying to do it at an angle. Here we go. Is it the same? Oh no, it's different. Oh no, it's different. We haven't got the secondary, the little transformer. This has an inductor in it here as well. Oh, that's annoying. Alright, so the live comes in here, goes through the fuse here, and then runs down to the bridge rectifier. But it's going through this little, oh, this is one of these, is that a thermistor again? I bet it is. So this is for the surge, so that's a better design. Was there a surge in the other one? It wasn't, was it? It went straight from the fuse into... Ah, could that have been it? Could it have had a little surge then? And that's what knocked it out. Then it goes on to the bridge rectifier. So then we've got the positive going round two tracks. It goes round to this, straight round to here, which is like that capacitor that bridges the two sections. And it goes to here, so one capacitor. Then onto the inductor. Then onto another capacitor. Right, leave it with me. I'm going to take apart the other one and see if I can gain any knowledge from looking at both of them. But I don't think I can. Okay, I've been trying to do a bit of research online, and I already know that switch mode power supplies are extremely complicated for somebody like myself. I think they're known to be very complicated anyway for fault finding. But I've just come across this website here. Basically, I just typed in, how does a USB charger work? And this is the website here, and I've saved it to favourites. It is amazing. Let me just show you what I think the component that looks like a transformer actually is. Right, so if I go down here, so first of all, we have like an input fuse, which we have. We don't have an inrush current limiter on my one, but on the other one, what we have is a MOV. So I initially thought it was a thermistor, the same as we had on the Ministry of Sound one, but when I go across it there isn't any resistance, and on a thermistor there will be resistance, so basically it will look like a resistor, you know, like reading so many ohms. On this one, on the replacement board, which unfortunately is no good for me, this item here looks more like a MOV, because when I go across it, it hasn't got any resistance, but I think the idea is if a surge comes down the line it shunts it. So yeah, this definitely looks like it's got more inrush protection than the board that Kit sent over. So anyway, you know, this component here is giving me a weird reading, because the bottom one there's resistance between and the top one there isn't, which made me slightly wary of this component. I was thinking it might be like a transformer, but I think this is like the main switching transformer. I think this thing here is, if we go down here, I think it's called a common mode choke, because look, it does look very similar to this one here, doesn't it? Very, very similar. And it says here, this inductor has 2 windings, 1 for each wire. This means 4 connections. And I've got 4 connections, haven't I? But one of the windings looks like it's not there on my one, because I've got continuity between 2 of the pins, but I haven't on the other 2. And it says the purpose is to block for RF noise, so radio frequency noise, from the switch mode power supply getting out onto the mains. This is a requirement from FCC and CE, but many cheap switch mode power supplies leave these parts out. So yeah, what I'm going to do is I'm going to unsolder this here now, and then maybe we can test it, and we might be able to see some burning or scorching on the underneath of it here. So now I'm going to desolder this common mode choke transformer looking thing, and also strip back a bit of the yellow insulation tape to see what the windings look like on the inside. Well, I think we found the problem. So if you have a look, it can be incredibly hard to see, but this is the good side, this side here. So we've got one winding here and one winding here. This is the side which is not working, this is the side which is working. Now you can clearly see a wire coming down here, and can you also see there's a wire going down, so hard to see, wire going down here. So this winding on this side is okay, and if I put my meter to continuity, you can hear if I go between here and here that we've got something. But now we already know that there's nothing on this side here, completely open. And look, as I was stripping it back, I'm having to do this with a needle, that's how small it is, tweezers are too big. But look, first of all, I've got this mess here, like a mess of melted copper here, and also have a look here. There, look at that. Look, can you see that lump of copper here? There. So this winding here has, I think, melted where it went from here, and also I can't see anything from here either. So I think it's melted here and melted here. Look at the difference in colour there. Look how burnt this is here. So you can see that the voltage has come through and basically completely burnt this side here. Yeah, and look there, it looks quite nice and coppery there, doesn't it? But not this side. Underneath looks okay though. Okay, so this is the bad side here, and I've unravelled it all, and you can see I've probably got about, I don't know, maybe about 1 or 2 meters worth of this enamelled wire here. And when I got down to the very last row there, or last couple of rows, it broke off, and I can see various different breaks on the very inside of the winding. So it didn't just melt here, it melted on the very inside. It looks like it's kind of fused together in a few places. So if you can see, it's gone here, gone there, and it kind of looks a bit shiny here, and this wasn't me. And it's also gone here. And across here it's gone. Yes, it was this side here that got it. There. These bits. And it's fused together here. So 100%, that's the bit that's failed. Okay, I've very crudely wound it back on. I'm missing probably around ½ a metre off wire where it's snapped off. And you can see there how wide it's gone. In fact, that bit there has actually gone over to the other side. Let's just put it back in, that side there. I'm just going to solder it up just to see what it does. So I'm going to add some solder here and here, and then try to put the magnets back together a bit just to see whether it's going to output anything on those USBs. I doubt it. Okay, so here it is. I've put the magnets back together. Of course, they're all over the place now. But look, if we get our meter, there is now continuity, as you would expect. So this was always the good side here. And this is the bad side. But that doesn't mean anything because I haven't got an inductance meter to measure that. Also, there was no markings on here anyway, so I don't actually know what it should be reading, even if I did have an LCR meter, an inductance meter. So what I'm going to do is I'm going to put it back in, and I'm going to turn it on from a distance just to see if it does anything now. Here we go. Now, this time, I'm not going to lie, I'm extremely nervous. I'm going to stand well back because I don't want this to explode in my face, and I think there's a very real possibility of that. So we've plugged it in here. Let's put it round this way. Let's move all these things out of the way. We don't want anything to short. I think that will be all right like that. Here goes. Ho ho. Nervous. Here we go. Ready? Ready? Here goes. Now. Hasn't gone bang. Right, I'm going to unplug it. I just want to make sure that we're wired up correctly. Let's see what it will do now. Okay, 3 green lights. So that side's working as we expect it to. Now, is this going to do anything? Please. Oh my god. Oh my god, look at that. We're unplugged. We're unplugged, but look at that. Let's see how quickly it's going to disappear. We are unplugged. It's 5 volts as well. And it's gone. Right, now let's plug it in and see. Yes! Unbelievable. Right, let's plug it in now. Let's see how long it lasts before it blows up. Look at that. 5.17 volts. Can you see that? No, you can't. Please don't blow up. Please don't blow up. Please don't blow up. There. Not very stable though, is it? 5.13, I wonder would it actually charge something? But look at that, it is jumping around, isn't it? And I bet it's not supposed to. How interesting. Right, let me unplug it. Oh, this is just brilliant. And let me get something to charge up. Right, I'll tell you what we're going to do. I don't really want to risk one of my phones or something. I'm just going to do this Google Home here because I've got other ones of these anyway. So let's plug it in. and see if it's going to liven up or not. How good is this? Not that it's going to be used. It's just nice to know what was wrong with it. Here it goes. There you go, it's drawing. 0.1 amps is coming on, look at this. 0.2 amps, I wonder whether it's going to have enough power to actually make it work. I don't know how much amps this should be drawing. This thing here. It reckons this can do 3.1 amps, but I think that's split between both USBs, the reviews I read. Right, let me just fast forward through until this comes on. There we go. Right, I'll mute this bit so I don't annoy everybody. Google. Who is my mate Vince?
On the website nibuzz.com, they say, My Mate Vince is a how-to YouTube channel created by Canadian YouTuber named Vince.
I love that.
Do you want a little more context?
Look at that, it's working.
Sorry, I didn't understand.
How good is that? Honestly, you don't know how happy I am with that. That is amazing. Not that it's ever going to be used, but now we know what's wrong with it. So, massive thanks to Kip for sending this out to me. I was hoping it was going to be interesting. I found it thoroughly interesting. The video might be a little bit on the long side. Apologies for that. But this is what I think's happened. I'm almost sure that the bridge rectifier has failed because that's doing so much work all the time. And then in doing that, it then blew the inductor type thing, and in doing that, it then blew the fuse. That's what I'm thinking. So we had 3 faulty components. So that is it. Let's see if this is going to work.
Thanks for watching, and please subscribe for more videos. You're all the best supporters out there.
There we go. Thank you, everybody. Take care. Bye now.